A pollster stands on a street corner. She can't ask every citizen in the country. She surveys 1,000 and extrapolates. But how confident is she? What if she surveyed a different 1,000? The answer: survey the survey. Resample from your own data and measure the variation. This is the bootstrap, and it's one of the most powerful ideas in statistics. The fundamental problem: you have a sample, not the population. The sample mean approximates the population mean. The sample correlation approximates the population correlation. But how close? The standard error quantifies this uncertainty. For simple statistics like the mean, formulas exist. But for complex statistics, the median, the ratio of two means, the eigenvalue of a covariance matrix, there's no formula. You need a general purpose method. Efron's Bootstrap, 1979. The idea: treat your sample as if it were the population. Draw a new sample of the same size with replacement. Some observations appear twice, some not at all. Calculate your statistic on this resample dataset. Repeat 1,000 times. The distribution of Bootstrap statistics approximates the sampling distribution of your statistic. The spread of Bootstrap estimates approximates the standard error. No formulas, no distributional assumptions, just resampling. Bootstrap confidence intervals. The simplest, the percentile method. Sort the 1,000 Bootstrap estimates. The 2.5th percentile is the lower bound. The 97.5th is the upper bound. That's your 95% confidence interval. The BC method, bias corrected and accelerated, adjusts for bias and skews and gives better coverage. Unlike normal theory intervals, Bootstrap intervals don't assume the statistic is normally distributed. They work for medians, ratios, eigenvalues, anything. The Jackknife predates the Bootstrap. Leave one observation out and recalculate the statistic. Repeat for each of the n observations. You get n estimates. Their variation estimates the standard error. The Jackknife is less flexible than the Bootstrap but computationally cheaper and useful for detecting influential observations. Let's use Jackknife to test the robustness of the popPK model. Leave one monoclonal antibody out of the 27. Refit the model. Check if the parameter estimates change. If removing one antibody dramatically shifts the results, that antibody is an influential outlier. In population pharmacokinetics, the Bootstrap is the standard model validation tool. Resample subjects with replacement 200 times. Fit the popPK model to each Bootstrap dataset. The distribution of parameter estimates gives confidence intervals. These are the 95% CIs in Bet's table 2. The visual predictive check takes this further. Simulate concentration time profiles from each Bootstrap bit. Overlay the 5th, 50th, and 95th percentiles on the observed data. If the model is correct, the observed data falls within the prediction bands. The Bootstrap, resample your data, measure the variation, get confidence intervals for anything. The Jackknife, leave one out, detect influential points. Both turn a single dataset into a distribution. Next, what happens when you shuffle the labels?